In this session, I will discuss about the introduction to regression analysis. Regression analysis is, we can say this as a technique of identification of relationship between given two set of variables. Therefore, but when we discuss about the correlation, using the correlation also, we have done the same thing. It is quite using the correlation, we have obtained a value as the strength of the relationship among any two given variables. But in the regression analysis, what we are going to do is we are going to identify the relationship in the form of equation. It is quite same as a model. Therefore, we are going to derive a model which says about the strength of the relationship. Therefore, in the regression analysis, we are showing it in the equation form. And when we are going to perform this regression analysis, not as previous. In the previous one, we had the one set of x variables were there, x variable was there, and y variable was there. But you can interchange the variables in the correlations. But here, definitely we have to identify what should be the x variable and what should be the y variable. It is because when we are going to discuss the basic regression analysis, there are two types of variables we need to consider. One type is dependent variable, another type is the independent variable. Therefore, in general, we are saying dependent variable as y variable and independent variable as the x variable. And here we are just obtaining form it is quite like equation form for the regression. We will just get the relationship among the set of variables in the form of equation, and we can still use this as obtained equation to estimations for dependent variable for a given value for independent variable. It means simply if you get this as y equals mx plus c, a simple model I will take. If this is mx plus c, and if you estimate this model, if you know the value of m and x, then for any unknown value of y can be obtained using the value of setting x to a defined value. Therefore, in general, we are saying this as the dependent variable, and y is meant to be the dependent variable. Therefore, if you are setting a value for independent variable, then using this equation, you can simply calculate the value for the dependent variable. And now we will see the differences between the correlation analysis and the regression analysis. In the correlation analysis, it describes the relationship between the linear relationship between the two variables. Therefore, if that is why at the initial step for the correlation analysis, we have obtained the scatter plot. Using the scatter plot, we have identified whether there is a linear relationship among the variables. If it exists, if it suggests that there is a linear relationship, then we can perform the correlation analysis, and we can use the correlation analysis to identify or measure the strength of the linear relationship among the two variables. But in the regression techniques, we can identify the linear relation, or else the nonlinear relations can be also identified. Therefore, regression analysis is not limited for linear relationship, but it can be also applied for nonlinear relationships also. But in this section, I will just discuss about the identification of the linear patterns using this regression analysis. But in here, you can just in the correlation analysis, there was one way y variable and one x variable. But in the regression analysis, we can perform it using one y variable with one or more x variables. It means that there may be several x variables associated with y variable. Therefore, this is the main difference. But if you see about the other differences between correlation and regression analysis, in the correlation analysis, we are measuring the strength just using a value. But in the regression analysis, we are obtaining an equation to measure the relationship among the set of variables. And the next thing what we can say is in the regression analysis, since we are obtaining an equation form, You can use the equation to estimate the values also. And in the correlation analysis, you can interchange the variables. You can define one variable, any given variable as x and another variable as y. But in the regression analysis, you cannot just name it as x and y. You have to carefully go through examine the data set, and thereafter you have to identify what should be the x value and what should be the y variable. What is the x variable and what is the y variable. It means that the x variable can behave itself. It means that x is the independent variable, but y is always dependent on the x variable. That is why we are saying y as the dependent variable. These are some names that we use to identify x and y. Where x is, we can say x as the independent variable, control variable, regression variable, or the explanatory variable. But we can name this y variable as dependent variable or the response variable, or we can say it as the study variable also. According to the situation, we will use the name, but anyhow, x is the independent variable and y is the dependent variable. And now we will just move on the simple linear regression. If you are going to perform the regression analysis, there may be several categories for the regression analysis. Therefore, one such category is the simple linear regression. In the simple linear regression, we are going to identify a relationship between one dependent variable with one independent variable. It means that there is only one x variable. If it is a simple regression, there would be one x variable and one y variable, and also here we are going to identify the linear relationships only. We are not going to identify any non-linear relation. It is because in the term itself it says that it is simple linear regression. Linear is the linearity behavior, and simple means that there is one independent variable with one dependent variable. And we can use several methods to fit fit a straight line. It is quite like this. Now think about, if you have given a data set in this form. Now think about, if you have observed set of values and if you obtain this scatter plot. If this is x-axis and if this is y-axis, and if you simply write down or just noted these values that you have obtained here, then you one may suggest that okay, I will be able to uh, fit a line in this form. You may say that okay, I am fitting a line in this form. Another person may say that okay, this is not a perfect line, the perfect line should be this. And anyone may say that okay, this can also be a possible line. Likewise, there may be several tentative models that we can fit for any given set of data, but there should be only one uh, line which satisfies most for this set of data. Therefore, when you are fitting a line, you have to identify the best fitting line. Therefore, to identify the best fitting line, we are using the least scarce method. Therefore, using the least scarce method, we can identify what is the best fitting line in the regression method. It is because according to the line that you are obtaining, if you are obtaining a line, then you may get this as in the form of y equals mx plus c. You may get the form of a line is y equals mx plus c. Therefore, there may be several values for m and there may be several values for c. But anyhow, you once you are fitting or once you are using a best fitting technique using the least square method, then there will be only one best fitting model as the y equals, if you are taking this as m and c. If this is the fitted value of m as the m hat, or the estimated, and then x and the c. Therefore, these are the fitted values that the estimated values for the best fitting, and therefore there would be only one model which is in this form. Therefore, now we'll see how to use the least square method to obtain these values. It is because if you have fit a linear model, then you need to identify this value of n and value of c. But in mathematics, in generally, we are defining the linear form as y equals mx plus c, rather than using n and c. Here, we like to use it as the beta coefficient and the beta naught and beta 1. Therefore, if this is set of points we are having in this form, and I told you that there is only one best fitting line, and the best fitting line is in the form of y equals beta naught plus beta 1 x plus error. But this error term vanishes once you use the least square estimation technique. Therefore, once you use the least square estimation technique, then you will end up with this form as y equals here beta naught plus beta 1 f. But even though you are vanishing this or you are making this epsilon to 0, it is the error terms. Therefore, since you are using the least square method, these values should be the estimated value. Therefore, this is what we are considering as the equation for the uh, simple linear regression using the least squares method. Therefore, it would be y equals beta naught hat plus beta 1 hat times x. And here you can match it with this equation. Here it is quite as y equals. If I take this beta 1 as the latter term, then I will take this as beta 1 hat times x plus beta not hat. Therefore, this is how we are performing the calculation, and this beta 1 hat is the value of m and beta naught hat is the value of c. Therefore, this is how we can perform the calculation to obtain uh, this equation, and we can say that beta naught is said to be the intercept parameter. Here you can see that beta naught is the intercept and beta 1 is said to be the slope parameter. Therefore, these are the uh, two quantities that we need to identify if we are fitting a simple linear regression model. And these are the two equations that we use to fit the simple linear regression. And these equations have obtained using the least squares method. Using the least square method, we can obtain these two equations. The first equation is it is the beta naught hat equals to y bar minus beta 1 hat x bar. To calculate the beta naught hat, you need to obtain a value for beta 1 hat, and you need to substitute it in this equation along with this y bar value and x bar value, where y bar represents the sample mean of variable y and the sample mean of the data set of x. And you have to use this equation to calculate the value for beta 1 hat. Therefore, prior to calculate the beta naught hat, it is better to calculate beta 1 hat, and this value would be used here to calculation of beta naught hat. When you are calculating the value for beta 1 hat, you need the summation of xy is needed, and then x bar is needed, y bar is needed, as well as the summation of x chart is needed. Therefore, if you are performing, if you need to perform the calculation for data set in this form, generally we are having the columns for x and y. And if you need to calculate the regression coefficients, we are saying this as the regression coefficients. Therefore, to calculate beta 1, we can see that xy multiplication is needed as well as the x squared term is needed. Therefore, you have to take the summations here. Summation x is needed to take, summation y is needed to take, summation of xy is needed to take, and then summation of x squared is needed. Thereafter, you have to substitute the summation of xy in this place. Then you can substitute summation of x squared in this place. And you can calculate the value of x bar. X bar can be calculated using summation of x divided by n. Y bar can be calculated using summation of y divided by and n is the number of pairs of observations you are having, then you can identify the value of n also. Then you have to use the formula to calculate beta 1, and then use this value here to calculate the value of beta 2. Therefore, this is how we are using this technique to calculate the parameters for beta naught and beta 1. And this is according to the value of beta naught hat, beta 1 hat, we can say that whether there is a positive relationship, negative, or no relationship. You all know that when we are discussing about the types of graphs, then we can say that according to the it is in form of y equals mx plus c. Then according to the value of m, based on the value of m, you have identified whether it is a it has upward trend, downward trend, or else it is parallel to its axis, or parallel to y-axis. Generally, we consider these two cases. Therefore, in here you can see that if we are having m as a positive value, we have identified it. If m is a negative value, we have identified it. If m is 0, we have identified this graph. Therefore, according to the value of m is plus, m negative, and then if m is equal to 0, then we have identified these three patterns. Therefore, these the same patterns will be also used in simple linear regression. Now instead of m, you have defined this as beta 1 hat. Therefore, m is now defined as beta 1 hat. Therefore, according to the uh, sign of beta 1 hat, we can identify whether there is positive relationship, negative relationship, or no relationship. If the value of this beta 1 hat is greater than 0, then we can say that there is a positive linear relationship. If beta 1 hat is less than 0, then we can say that there is a negative relationship. And if this beta 1 hat is 0, then we can say that there is no relationship. It means that line is parallel to x-axis. Therefore, based on these values, we can say that whether there is positive, negative, or no relationship among the set of data sets. And this is an example we can consider. Uh, Here in this data set, they have measured age and heart rate. This is the set of data we have identified. And according to the cardiologist, that person needs to study to identify how is the relationship among the age and the heart rate. Therefore, in here, he has performed an study and identified or observed this set of values for age and this set of values for heart rate. It means that for a patient with age 30, it was considered as it is not actually the heart rate, it is the we can see it as the blood pressure. Or person's heart rate cannot be this much, therefore this can be considered as the blood pressure. Therefore, in the blood pressure, that person has considered a patient with 30, 190, another 30 years patient, then 180 was observed, then 40, 180 observed. Patient with 20, 200 observed. Likewise, the values were observed, and here you are asked to identify, just take this as example only. Therefore, here first of all, you have to construct a scatter plot. Therefore, by considering this set of pairs, then you can simply construct this scatter plot. But when you are constructing, prior to construct the scatter plot, we need to identify in the regression analysis. I told you that first of all we need to identify what should be the x variable and what should be the y variable. I told you that x should be always the independent variable and y should be the dependent variable. Therefore, according to situation, you have to identify it here. Uh, Heart rate may be depend on the age, but age may not be definitely depend on the heart rate or the blood pressure. Therefore, here we can consider age is the variable and heart rate or the blood pressure is the y variable. It is because uh, heart rate may be or the blood pressure may be depend on the variable or the age variable, but age will not be vary according to the heart rate varies. Therefore, heart rate and the blood pressure varies. Therefore, we have to identify age as the variable and the heart rate as the y variable. Therefore, first of all, you need to identify it. After that, you can construct the scatter plot, plot the value in the x-axis and the y-axis accordingly. And thereafter, what they ask you, first of all, you are asked to compute the correlation coefficient. Here in simply says coefficient of correlation, it says that you are asked to calculate the Pearson's correlation coefficient. Generally, we are not going to say it as Pearson correlation, we simply say we are saying it as correlation coefficient. After that, you are asked to calculate the regression coefficients. You can use these equations to calculate the regression coefficient, and thereafter you ask to predict the heart rate of the individuals with age of 45 and 40. Therefore, you can find for this exercise by yourself. All the uh, needy equations are given in here, and uh, this is what I need to discuss for the introduction for this, and therefore thank you all for joining.